Hey, what's up everyone? Welcome back to the channel. Sorry it's been a while, but now we are finally back with another simple sensor tutorial. And today's quick tutorial, I'll be showing you how to wire a camera to the Raspberry Pi Pico 2W and take images using the device and save those images on the device itself. So we'll have a very simple setup today where we'll just wire this Arducam 2 megapixel camera to the Raspberry Pi Pico 2W. And once we're done wiring it, I'll be walking you through the code and library setup in CircuitPython and Thonny on the device. So we'll just have a simple script, which will be available on ShillehTek.com in the blog section that you can run on the device, and it will just save images on the device directly, which we can eventually port and view on our local computer. So if you want to take images with the Raspberry Pi Pico W, this is the video for you. So tag along, and before we begin, be sure to like, comment, and subscribe to the channel. Visit ShillehTek.com if you haven't as well to go check out the blog to follow along in more detail, and let's get started. Okay, so first things first, we just want to connect our camera to the Raspberry Pi Pico W. So you see in this image here, this is how it looks in real life after we set it up. So I'm just using a breadboard to hold things in place, and of course you want to take a set of jumper wires. And just to show you the connection in a bit more detail here, I set it up in fritzing as you see. So we need, I believe that is 1, 2, 3, 4, that is 8 jumper wires. And pretty much we just set up exactly as we have here. And of course, more detail of the connections on the blog in the link down below. But pretty much just match these connections as you see. So we have some for VCC and ground. So we obviously have to power the camera. So we're gonna connect that to the 3.3 volt pin and the ground pin. And then we have STL and SDA pins. So we connect that to pins 12 and 11 respectively. And then we have the 4 pins for SPI communication. So this is actually how we're communicating with the device to actually get those images, and that is through SPI interface. So we'll be using these 4 pins, and we'll be wiring them in this segment over here. So that's pins 7 to 4. And we'll be using the MOSI, CS, and SCK pin, serial clock pin. And once we have those all wired, just go ahead and plug your device into power and connect it to your computer. And we'll be talking about the library setup. Okay, so now that we have the physical connection, let's go into our Thonny IDE. So make sure you have Thonny installed. You could see my device is plugged in. But actually, I forgot to mention, if you've never used CircuitPython, it's pretty much another version of MicroPython that's built for other types of applications and has different types of libraries you can use with it. We're going to install CircuitPython on the Raspberry Pi Pico 2W. I already have installed, but I'll show you how to do it anyway. So go ahead and just unplug your device. And once your device is unplugged, you can go ahead and hold the boot cell button, plug it back into the USB, as you see here. And then once that is plugged back in, we can go to the bottom right here, install CircuitPython, and we could just walk through these drop downs. So it finds the target volume automatically, RP2 variant Pico 2W. Now this tutorial will work fine with the Pico W, so if you are using the Pico W, that is also fine. And just install the latest version and go ahead and click install. I already have it installed, so I'm not going to install it again. And once it's installed, you can just go ahead and unplug and plug the device back in. Give it a moment, and your device should be found on the bottom right there. So give that a quick moment. You can see that it's mounted. And now we have access to the device in CircuitPython, and it comes with these base libraries and whatnot. I already have this images directory I made. If you haven't already, just go ahead and make the images directory, because that's where we'll be saving the images. And once we have this, let's go ahead and get the library from Arducam and put it on the device so we can actually use this library to run commands to take images with the camera. Okay, so now we just want to get the library code to be able to use the camera on the device. So go to this link in GitHub, which is in my blog down below. They have some instructions here. I thought they were a little confusing, so I'll just go ahead and make it simpler for you. You can go ahead and download the repository here. So go ahead and download the zip. I just use git clone to download it. So I'm just going to take this. I'm going to get the HTTPS link, and I'm just going to CD to my desktop and just download it from there. So we could just do git clone. If you use git, it's pretty much the same as downloading it. I just prefer to do it like this. So give that a moment to download. And once that is downloaded, so we have all the files. So what we want to do is we essentially just want to move all the files from the Python directory onto the Raspberry Pi Pico 2W. So in order to do that, let's just go back here. You can see we are in the Thonny editor once again, and we should be able to find that library as we see here. So we can just navigate on our desktop in Thonny. If you haven't before, that's in the top left in the editor. And so I have those files on my local computer. So on the bottom is my CircuitPython device, which is connected. And we could just select all these files and just move them onto the device. So we could just do this. And then we could just upload to the Raspberry Pi Pico W. So give that a moment, and it will eventually reach our device. Okay, so just a few more steps left here. We just want to modify some of the code we retrieved from the library. So the first code we want to modify is actually this boot.py. So go ahead and open this boot.py, go ahead and save this, and we can just click save. And then we just want to unplug and plug the device, because without this, it will make the image not be able to save on the internal flash. So let's go ahead and unplug and plug. This boot.py runs as soon as the device reboots. So we just did a hard reset. Go ahead and connect again and just close that to make sure that it's saved properly. So this is the boot.py. Looks like it's saved properly. And now what we want to do is, you see this code.py file. What we can do inside this code.py file is we could just copy this code. Now I'm not going to go over this code really into depth, but this code is just going to take an image with one of the settings we have, and it's just going to save the images to the image directory. So make sure you have an images directory. Once again, you can create a new directory here. So this code is code I wrote offline. Pretty much what it is doing, it is just taking a command. So that command is just pretty much setting the resolution. So we could just set the resolution to whatever we like. I'm just going to set it to 08, which is a higher resolution. So we can go ahead and save that. And then once we have this code, what we could do is we could simply run it. So it will initialize the camera using the OV2640 class. You see there's another class with a 5 megapixel camera. We actually don't even worry about that because we're using the 2 megapixel version. So we're going to initialize the OV2640, 2 megapixel camera with the correct resolution. And then we are just going to capture an image. So there's just some library logic happening in the background that we're frankly don't have the time to go over. So I will leave that up to you to understand how this code works in more detail. But what we want to do now is simply just run this code. So if we did everything properly, our camera is here on our device. What I will do is I'll just point at my computer, I'll take an image, and I'll show you that that image is as expected. So go ahead and run this code. So it's initializing camera and it's saving it. So if you wired everything properly, you modified the boot.py and you hard reset your device and you ran this code.py, you should see the new image in your images directory here. So that is 0093. So what we can do now is we can simply go and we could just move this back to our local computer. So let's just move this to our desktop actually to make it easy. So we'll just do that. So download this image to the desktop. And so I just pointed on my computer. So just to prove to you that it works, we can go ahead and open that same image. So we can just open the 0093 and you could see it's not very clear, but because I was moving it around a bit, but it does give a decently resolute image. And of course, there's many other settings you could play around with on this camera. Looks like it was able to take an image successfully. Let's just do one more in my living room and show you that it looks better when it's not moving around. So I'm going to do one more just to prove to you that it works as expected and it's nice. So we could just go ahead and run this one more time. So, oh, I ran the wrong code. Let's run code.py. So opened, it saved a new image, which is 0160. So give that a moment to show up. I don't know why it hasn't. So there it is. And we can go ahead once more and download to our desktop. Okay, so now going back to my desktop to look at that image now that it's downloaded, looks better. Now things are far away, so it does do better with that resolution when you are looking at farther away objects. So that's just the corner of my room. But yeah, I guess you get the gist of it now that you could see it could take images and you can play around with the resolution and settings as you like. So there you have it for today's tutorial. You saw how incredibly easy it was to take your first images on the Raspberry Pi Pico 2W using the Arducam 2 megapixel. I hope you got everything working as expected. If you did, please be sure to like, comment, and subscribe to the channel. Let us know what you want to see in the comment section down below, or if you have any questions or concerns with today's video. I hope you got it working, and also I hope we can continue to build off the application we built today in future tutorials, where eventually we will show things integrated with AWS and other cloud platforms, and also integrate other peripheral sensors such as motion detectors, where we can take images based on motion being detected from a human or an object, which is great for remote monitoring and security applications, which is really popular for IoT. So many ways we can build off of what we learned today. So stick around with us to see more of that on the channel. Thanks for watching, guys, and I will see you next time.